Okay, well, I think we'll probably get started. We might have a couple of people trickle in as we go. Hi, welcome. Thank you for coming. My name is Joel McKim. I'm a reader in digital media and culture here at Birkbeck and the director of the Vasari Research Center for Art and Technology. Broadly, I'm interested in digital images. I'm interested in how changing technologies impact the production and circulation of images, and how these images interact with a wider material, aesthetic, economic, and social realm. So hopefully the talk this evening will kind of indicate some of the ways in which I approach image culture in this kind of wider terrain. Um, Very happy to be the second in our amazing series, Critical Voices on AI, for a Birkbeck series. We had a great beginning to the series last Thursday. My colleague Alex Gronkowski from Philosophy talking about ChatGPT and wondering whether ChatGPT thinks. I was really happy to see Alex's talk because I think the two talks work quite well together. Where Alex is talking very much about text and large language models, and I'll be focusing on images. But many of the kind of underlying issues, philosophical, political, social, are similar. And so I think they're a nice kind of companion to each other. And just a reminder that there are two more talks in the series by Kinga and Felix, one on November 28th and one on December 3rd. So please do try to make those as well. Thank you for the Birkbeck Institute for Data Analytics for putting on the series and bringing us all together. There will be a drinks reception after the talk, so you're very welcome to join us for that. The talk will hopefully be about an hour, and then we should have half an hour or so for questions and discussion. There will be a roaming mic for that discussion period because we do have an online audience as well. One of the kind of occasions for putting on the series and bringing some of the people at Birkbeck who are looking at AI from a number of different perspectives together is the launch this year of our MA in AI Ethics and Society, which Alex has really kind of led the charge with and is the director of that program. So if you are interested in some of the ideas that you'll see through these talks and might want to explore it further through an MA, please get in touch with Alex or any of us. So let me kind of hop in. In 2021, at their annual, oops, 2021 at their annual GPU Technology Conference, NVIDIA announced their Earth 2 project. The Earth 2 simulation is indicative of the threshold of ambition laid out by the tech giants of AI, a CGI model on a planetary scale powered by AI and residing in NVIDIA's Omniverse, capable of simulating everything from atmospheric weather patterns to street level traffic flows. And I'm sure by this time we're all familiar with NVIDIA, the kind of rising power within the AI tech industry. And responsible for producing the GPUs, the graphics processing units that are powering not only the AI machines, but also all kinds of digital image technology from video games to graphic design and so on. And one of the only AI companies to be profitable at this stage, as some commentators have said, if the current AI revolution is a gold rush, NVIDIA makes the shovels. And they're doing pretty well. So by 2024, NVIDIA CEO Jensen Huang provided a kind of update on the Earth 2 project. And he said, the idea that we could create a digital twin of the Earth, that we could go and simulate the Earth so that we could predict the future of our planet better. The Earth 2 digital twin is probably one of the most ambitious projects the world has ever undertaken. So it's kind of against this backdrop. I mean, we'll make our way back up to this kind of planetary scale, and the notion of AI setting its sights on world simulation or world modeling. The amount of hype that's kind of gone into the AI industry, in order to kind of satisfy that hype in some ways, that's the kind of scale at which the large AI tech companies need to be thinking. But I want to start at a much more modest scale and trace back some of the AI image technologies that have brought us to the point we are now. I'll start at 2015. We could start earlier, but this is an important moment, as it's the first text-to-image generation experiments to be realized. A project called Align Draw out of the University of Toronto. This is, I'm sure you can see very clearly that this is the realization of a prompt for a stop sign is flying in blue skies. The project's significant for a number of reasons. As I say, it's the first kind of realization of text-to-image technology, but the kind of blueprint or the working parts of our current generation of text-to-image technology was already in place to some degree. There's early kind of experiments with transformer models. Alex gave us a really good and concise summary of some of the kind of innovations that have come through transformer models. We'll talk about that a bit more. But it's not really until 2021 that the text-to-image generative AI revolution hits images. It's significant that this is, you might notice, we often think of the generative AI moment as beginning with the release of ChatGPT in November of 2022. But the beginnings of interest in text-to-image generation predate that by some time. So we have this kind of, by now, kind of iconic image of the avocado chair. This is like ChatGPT. This is the beginning of DALL-E. So DALL-E, a kind of portmanteau of Salvador Dali and WALL-E. It's also released by OpenAI, the creators of ChatGPT, and borrowing and intersecting in many ways with some of the technologies in which ChatGPT exists. It's not until 2022 where the possibilities of this technology really enter into public circulation. So we have a series of launches. We had DALL-E 2 in April 2022, Midjourney in 2022, in July of 2022, Stable Diffusion in August of 2022. All of which still, as you may notice, a couple of months before the launch of ChatGPT. These models have come quite a long way in that time. Actually, the dates on the last two of these should be 2023. But we already have, actually, for a model like Midjourney, we're up to version 6.1. And you can start to see the kind of development of increasingly photorealistic images. And for image technology, that is the kind of marker that most of these models are aiming towards, is the holy grail of photorealism. So I ran my own kind of Midjourney experiment here. This is version 4, version 5, and version 6.1. Prompt, Birkbeck lecturer gives public lecture on generative AI. We can see maybe some kind of differences over time. A little bit greater detail, maybe a little more photorealism. Hands start to to behave a little bit better. But then I think significantly, and something we can talk about later, some things stay very much the same, right? Birkbeck lecturer, automatically white, male, that doesn't change. So I won't focus in this talks particularly on issues of the kind of cultural biases that exist within these models and data sets, but that's something we can certainly talk about. So this text-to-image technology is significantly different than an earlier generation of AI image technology. Things like based on generative adversarial networks and reliant on large-scale image data sets of, importantly, hand-annotated images, classification sets, effectively, such as ImageNet, which was created by Fei-Fei Li from Stanford. How is this different? So let's kind of get a little bit under the hood of some of this technology and look at some of the component parts that make up something like a text-to-image generator like DALL-E. Significantly, and I think Alex already kind of alluded to this, AI technologies are always many technologies. There are many models, there are many component parts, and it's, I think, important to do a kind of anatomical analysis of them to better understand how they work and the implications of where the components come from. One of the important elements of the current generation of generative AI is that it is reliant on very large data sets, as we know. And those come importantly from a kind of web scraping that was not previously possible. So ImageNet was reliant on things like common licenses for repositories like Flickr. That's increasingly more difficult. So initiatives like Common Crawl, which crawl the internet for images, text data, which feeds this kind of hungry machine of generative AI. These models are based on diffusion models. So the production of images through a process of training models based on adding Gaussian noise to clean images and training the model to be able to reverse the process and begin with random noise and eventually produce an image from that random noise. So the gradual process of image shapes, kind of generating out of this kind of field of noise. But what directs them, right? How do they accomplish that? How do we get a cat from random noise and not some other object or some kind of random form? And that's where, for image models, again, we're reliant on these text and image pairings. And so we have increasingly large data sets, lay on 5 billion text image pairs, which are used to train some of these generators. But that's not quite enough. That doesn't quite provide the kind of innovative factor which allows for these hyper realistic images to be formed. And there we have to look at something like another AI model. Again, this one produced by OpenAI and released at the same time as DALL-E, CLIP, contrasted language image pre-training. So CLIP works by, similarly to as Alex explained with ChatGPT, it's a transformer model. It's based on attention. The notion that the model is trained on recognizing tokens, which could be image, could be text, but importantly, understanding them within a certain context. And in this case, CLIP takes image and text data sets, feeds them into an embedding space or a latent space, and we'll look more closely at that term in a moment, and situates text and image in similar kind of spaces within the latent space. So let me try to explain the concept, because I think it's particularly important for image generators. So this is a video of a Google tutorial looking at high dimensional latent space. It shows the process of, in this case, it's a text sorting machine learning process in which these kind of high dimensional features of a data set are sorted and ordered according to meaningful features as the model reads them. So in this case, things like, I'll run that one more time. So this particular data set has each vector, each item has 200 dimensions or features. So the model sorts that into meaningful arrangements. Numbers, dates, names, locations. The same process can be done with images. So in this case, these are images of people hand drawing numbers. And the machine learning model sorts them according to similarity, visual similarity. So there's one more kind of step that we need to understand in terms of understanding what a latent space entails. It's a term that's circulates frequently around discussions of AI. The important element is that latent space is not only a kind of ordering space. We can imagine a kind of mathematical ordering space or numerical ordering space of features or weights. But importantly, it orders these component parts at a lower dimensional level of complexity. So if we have a high dimensional manifold of images, so an image is based on pixels, for example, the latent space will abstract from that higher dimensional manifold and produce an organization of data based on a lower complexity abstraction, which is nevertheless meaningful from the point of view of the model. When we go to extract an image on the other side, we diffuse an image into pixels to produce an image. We go from the lower dimensional latent space and extract that image and reproduce it at the higher dimensional space of an image. So importantly, this is an attempt to visualize the latent space of a text-to-image model like Stable Diffusion. So of course, this is very kind of these are visualizations or representations of something that is mathematical in nature and very difficult for us to kind of imagine in some ways, and certainly difficult to represent. So this is brought down to a kind of two-dimensional space. But the important thing is that in each case, the latent space is a representation or a processing of that data, but at a level of abstraction. It's in some ways we could consider it to be a set of kind of concepts based on the original high dimensional data set. And what's important, part of what's important in relation to text to image generators is that we are now working in a multimodal space. So rather than GPT, which is working in text alone, in language alone, we're dealing with text and image. And the latent space is able to organize those concepts, so those abstracted concepts from the data in both of those modes. So we have text concepts organized around image concepts, and later, as we'll see, even video concepts. So this allows us the model to understand not only our prompts, so if we ask it to produce a lecture at a podium, it's able to, in some ways, kind of reach into that latent space, find the area of that space which matches the requested information, and extract from that an image which is corresponding to that text information. So with the release of Clip, there's a kind of recognition by OpenAI that what they're doing is essentially representing a more complete understanding of the world, an understanding of the world that's based on both text and images. So as Ilya Sutskever, the chief scientist at OpenAI, says, with the release of the original DALL-E, we live in a visual world. In the long run, you're going to have models which understand both text and images. AI will be able to understand language better because it can see what words and sentences mean. So there's a notion that that kind of understanding or that level of complexity that the models are able to work with is accentuated by the multimodal nature of the data sets. Okay, which brings us to 2024. So 2022 is a busy year for text to image generation, and it's kind of incredible the pace at which things are moving, and the improvements in these models, the rush towards photorealism. By 2020, end of 2023, it seems like maybe things are slowing down, that people are able to catch their breaths to some degree, that perhaps the technology is maybe reaching a plateau, and that the large advances that we've seen in text-to-image generation may be slowing. But in February 2024, OpenAI surprises us again or throws us for another loop by announcing, not releasing to the public, but announcing Sora, a text-to-video generator. So let's just see a couple of the sample videos that OpenAI released to the public in February of 2024. I'm sure many of you have seen this already. OpenAI claimed that these were produced from single prompts with no additional processing beyond the generation of the model. This wasn't the first time that we had generative AI applied to moving image, to video, but the level of improvement, the level of realism, the level of consistency was pretty astonishing. And as amazing as that would have been anyway, the notion that text to video of this length, of this quality, of this consistency was possible would have been astonishing in any case. It would obviously very disruptive to moving image creation technologies of industry. But OpenAI goes even further to suggest that what they're actually producing in the case of Sora is the gateway to the possibility of world simulators. That video generation models, so again, we're talking multimodal models, but in this case, introducing movement as well as image, is a kind of opening or a possibility of extending to full world simulation. So they say our results suggest that scaling video generation models is a promising path towards building general purpose simulators of the physical world. And we can see in some ways why they might be making some of these claims. Cars seem to obey the laws of physical laws of gravity. They stay on roads. Dust emitted from tires seems to behave according to the laws of particle physics. Humans move in realistic ways and appear to retain kind of consistency. So perhaps these claims at first glance might not seem entirely far-fetched. But world simulators, let's take that claim seriously, but skeptically. But nevertheless, we have to acknowledge that the progress made in terms of these video simulators is a world away from the kind of generative video quality that we had in the not too distant past, which was based primarily on pixel recognition, on trying to introduce movement between still images, to try to, in some ways, produce a model that replicated our current modes of cinema by adding motion to still images, but understanding the images on a kind of pixel basis. This only gets you so far, right? The consistency between movement and images is not there. No understanding whatsoever of physical properties or the relationship of objects to context and so on. So Sora is an impressive move forward, seemingly. But what exactly is happening here? So let's sort of go a little bit under the hood of Sora and try to understand the way in which the models are actually working. And here again, we need to look at a kind of understanding of latent space and how it's being used in this particular case. So again, we have video. So Sora can be trained on both moving image, so video image, but also still images, as well as text, of course. That visual material which is high resolution, high complexity, incredible number of features or dimensions, which is encoded into the model and reproduced at the level of a latent space. So again, abstracted, reduced in complexity, organized around key features and important consistencies. OpenAI uses the term space-time latent patches to understand the underlying or the basic token which is populating these this particular latent space of a model like Sora, and the way in which Sora is actually understanding video footage and therefore developing an understanding of the world, an understanding of how objects work in context, the way in which physical properties can be approximated or simulated. So space-time latent patches, again, this is where the understanding of the model is not at the level of pixels moving across the screen, but is an abstraction of that pixel information into what we might call concepts of movement, image, and so on, in ways which have a kind of coherence or understanding that don't need to be manifested purely at the level of pixels, or at least so. To give an example, if Sora has video footage of a car driving, it's able to develop through the abstraction into latent space the notion of a kind of concept or a kind of consistent view of how a car behaves and how a car moving across the screen might be manifested. So it's not just a replication of thousands of examples of cars moving across the screen. It develops some form of understanding or conceptualization, abstraction of what that space-time latent patch consists of. So it's able to then replicate it or reproduce it at the other end of the model in a number of different variations, varieties, and so on. It's kind of an amazing process, obviously, but and then so then we have at the other end we have again a diffusion model. So we begin with noise, random noise, through which that kind of image of which is directed by whatever prompt we provide, eventually kind of takes shape, or the noise congregates around fixed images. They're reproduced as kind of single images, which are pulled together in video form. Compute matters here. This is highly kind of intensive, computationally intensive process. And OpenAI shows the kind of difference between the levels of computation and the gradual process of producing a more coherent, consistent, realistic image. It's kind of an amazing process. Of course, OpenAI has still not released Sora to the public nearly a year after the first announcement. But if it works the way they say it works, it's quite remarkable. But is it a world model? Is it a world simulator? Does Sora, even though it might have developed a certain kind of understanding of certain properties of image-based data, some kind of understanding of the way in which pixels moving in a particular configuration, in a particular order, might be translated into a kind of coherent or consistent concept, which could then be regenerated. Does this actually, can we call this a world model or a world simulation? Does Sora actually understand physics? Does it understand the world in a more kind of meaningful way or not? And this is the kind of level of debate. To help us with this, I wanted to turn to Catherine Hales, who I think from my discipline of kind of digital humanities is one of the most helpful thinkers around what we face today in terms of our relationship to AI and what exactly AI is. We were lucky to have Catherine Hales with us here at Birkbeck last January. This is her book, Bacteria to AI, which is about to be released by the University of Chicago. Hales's overall project at the moment is trying to, in some ways, find a definition of cognition that is consistent across both potentially living organisms and non-living organisms. So can we find a kind of what is the basic criteria that these both living and non-living organisms, conscious and non-conscious, might need to satisfy in order to reach the threshold of cognition? And she says 5 criteria are necessary: sensing, interpreting, responding flexibly, anticipating, and learning. Importantly, Hales does not use the word intelligence and prefers the word cognition. And importantly for Hales, as I mentioned, consciousness is not a prerequisite of cognition. Many things, according to Hales, demonstrate cognition, satisfy these criteria, but are not conscious. The notion of models is important for Hales, and so I think there's a kind of valuable guide here towards a better understanding of what constitutes a world model, and for us to kind of understand what it would mean for a generative AI system like Sora or another text to video generator, for example, to have something that we might realistically call a world model. So Hale says a model can be considered a generalization that has predictive power and survival benefits. She's talking in this sense for organisms. It originates in sensing and interpreting environmental information, but it goes beyond specific instances to anticipate how future events will unfold. So in a way, a model opens up the kind of possibility of anticipation and future thinking. In a sense, a model is the net result of all the serial components interacting together. It represents what an organism has learned about its environment, provides the anticipations that enable it to survive within its environmental niche. So models are key for Hales in terms of recognizing what constitutes an entity with cognition, with an ability to kind of understand its surroundings. In relation to, and Hales is looking primarily, Hales is a literature scholar and is looking primarily at large language models in her consideration of AI. She says, like humans, animals, plants for Hales definitely exhibit cognition. And slime molds, LLMs, large language models, gather information from their environments and learn from their experiences. However, their environments are entirely artificial, consisting of the human-authored texts on which they have been trained. So for Hales, large language models do actually satisfy the threshold of cognition, but the kind of modeling of their environments or worlds is particular. She goes on to say, in relation to the limitations of large language models, chief among these are its lack of embodied experience in the world and its absence of emotions, desires, and preferences. It has no model of the world, only a model of language, or more precisely, of language as it is used by humans. I have argued that these limitations constitute a systemic fragility of reference. So importantly for Hales, a large language model does have a model of an environment. It has a constituent environment, but that environment consists of language. There's no direct contact of a large language model to the larger world that surrounds it. So it has cognition. It is able to have an understanding of, in some ways, a certain kind of world, but a world constituted only of language. And that's an important distinction for Hales. But nevertheless, Hales sees the development of generative AI as hugely significant and of providing kind of new understandings, not only of the world of the AI models itself, but of our world, actually. She says it represents the first time in human history that a cognitive entity has the capability to verbalize the human Umwelt. So that's the term that we could translate to life world or environment in extensive and precise terms. In a similar fashion to how humans understand hummingbirds and octopi, that is from outside their Umwelten, so LLMs understand the human Umwelt from the outside. So for Hales, it's a kind of a hugely significant threshold that we've crossed, and that one of the biggest questions of our age is determining how the cognitive properties of AI and human cognition will interact and coincide. And importantly, she believes that generative AI provides us with yes, it has a model of a world. It's a world, it has a model of an environment constructed of human language. And as a result, it has kind of insights into our world in a bizarre sense, but from the outside, from this kind of alien perspective in some senses. Okay. The kind of skepticism of the level at which current generative AI is actually able to kind of model the world or simulate the world surfaces within AI discussions themselves. So Yann LeCun, AI scientist at Google, has kind of famously or infamously been a bit of a kind of wet blanket in some senses, and with the kind of hype around generative AI, and has been kind of skeptical about some of the promises being made about the abilities of these technologies to fully understand the world, or to model the world, or to simulate the world. And this is from a similar perspective as Hales. Hales is very much emphasizing the ways in which humans model their world or understand their world by being embedded within that world, by being embodied. And so that kind of embodied cognition, we understand physics, not through learning it through language or through studying in a book, but because we observe the world around us, and we're able to make those correlations based on our surrounding environment by being embedded within it. LeCun has kind of similar viewpoints in some ways. He says human and non-human animals seem able to learn enormous amounts of background knowledge about how the world works through observation and through an incomprehensibly small amount of interactions in a task-independent, unsupervised way. It can be hypothesized that this accumulated knowledge may constitute the basis for what is often called common sense. So some of the things that LeCun is emphasizing is, in some ways, the huge amounts of information that we are processing just by being in the world through direct or indirect observation, by embodied learning, and that we develop a kind of common sense about the world around us through that. And we're able to do it through a relatively small number of examples, tasks, and so on, unlike generative AI that requires massive amounts of data in order to come up with, in some ways, sometimes quite simple understandings of the world. He says common sense can be seen as a collection of models of the world that can tell an agent what is likely, what is plausible, and what is impossible. So without this common sense, without a model of the world, we hit a kind of threshold of understanding. So he says, I submit that devising learning paradigms and architectures that would allow machines to learn world models in an unsupervised or self-supervised fashion, and to use these models to predict, to reason, and to plan is one of the main challenges of AI and machine learning today. One major technical hurdle is how to devise trainable world models that can deal with complex uncertainty in the predictions. So the goal for LeCun, or the kind of path to the kind of next step in AI, is for AI to truly be able to generate or to have a kind of world model. But that requires a different approach. That requires actually training AIs through some form of trainable world model, which is not so self-evident. And he's very clear that he does not think that this is simply a case of moving along the same path of generative AI and simply scaling up the computation and scaling up the level of data. He thinks that there's inherent limitations in these kinds of forms of understanding that current AI is able to achieve. He says this idea that we're going to just scale up the current large language models and eventually human level AI will emerge, I don't believe this at all, not for 1 second. And I think if we look a little closer at Sora's output, we might agree with McKim. To OpenAI's credit, they do also kind of admit some of the limitations, their current limitations of the model, a kind of sometimes limited, inconsistent, and contradictory sense of physics, kind of revealing that perhaps the underlying understanding of the physical world is limited, partial at least, or maybe even faulty. But I just want to end by highlighting I think a really important article that was written recently by Louisa Moore, Alexander Campallo, Benjamin Jacobson, and Ludovico Rila, entitled "A World Model on the Political Logics of Generative AI." And so Louisa Moore and the other authors really kind of shift the focus of what we should be thinking about and concentrating on when we think about the relation of world models and generative AI. Rather than kind of obsessing over whether generative AI has a kind of model of the world, a kind of accurate or consistent model of the world, they instead place the focus on the notion that generative AI is instantiating a model of the world from its own logics. So we argue that large language models and generative AI are always already instantiating a model of the world, and with it a set of political logics and governing rationalities that have profound and enduring effects on how we live today. So they try to sort of understand the inherent logics of some of the kind of systems of AI that I've tried to, in a kind of fractured way, walk through in some senses. So for example, the notion of latent space and the implications of this process of abstracting, reducing, compressing information into a kind of latent space, which then produces outputs on the other end, the kind of implications of that process, the kind of political logic that is involved in that. And they, for example, look at the way in which the UK government has been encouraging AI developers to think of ways of making more efficiency into the process of asylum seekers and immigration, and the potential political consequences of running that kind of data, that kind of world question, through these underlying logics. So according to Louisa Moore and others, that there is a model of the world which generative AI has inherent to it, but it's specific to the logics of AI, and that model of the world is now being in some ways transmitted or transferred into our world, right? So it's kind of the reverse of the question. So the implications of this, just to sort of span out again to the kind of economic, the industrial, the big picture, I think we have to sort of question the motivations for some of the kind of claims that AI technology companies are making, and in some ways the kind of requirement that they work at this planetary or world scale, based on the kind of like size of the investment being made in AI technologies, the kind of literal financial investment, the promises being made. It almost has to deliver at this level of world simulation, world modeling, at this, the largest level possible. So a generative model like Sora, as amazing as it might be in terms of what it does to moving image production, that scale is not enough, right? It has to have implications for kind of world simulation, world modeling, and so on. And this is not going away. So these developments in the notion that world models are the kind of new terrain of AI, that this is the level at which AI needs and should be thinking and operating, continue. And so we have, for example, the announcement of the formation of World Labs, which is being headed by Fei Li. If you remember, the originator of the ImageNet image data set from Stanford. So Fei Li is now heading a group of AI developers around the topic of World Labs, which they say, we are a spatial intelligence company building large world models to perceive, generate, and interact with the 3D world. They go on to say, their goal is to advance beyond the capability of today's models. We need spatially intelligent AI that can model the world and reason about objects, places, and interactions in 3D space and time. Towards this goal, World Labs will develop spatially intelligent large world models, LWMs, that can be understood and reason about the 3D world from images and other modalities. Over time, we expect to train increasingly powerful models with broader capabilities that can be applied in a variety of domains, working alongside people. So the basic kind of building blocks or the kind of training sets which are being aimed at are now large world models. We don't know yet exactly what that's going to entail, but clearly this is where the AI industry is setting its sights, and I think we really need to kind of question the implications of that and the kind of world model that is being kind of unleashed on the world. I'll end there. Thank you.
Thanks very much. I just want to sort of get your idea about this idea of common sense. I remember talking to some people like 10 years ago, and even then some people already started to sort of question the idea of the common sense more than a common bias. So, these large language models are quite scary in the sense that, it's mostly trained by white males. It was about marginalized communities, it was about female populations. And again, the public sector is overwhelmed. So there are these amazing ideas to sort of make productivity better using AI and large language models. I think they are absolutely unsafe at the moment.
Yeah.
And I'm just wondering where you are on that point.
Yeah. No, it's interesting. I mean, the notion of common sense implies a certain kind of universality, which is probably inaccurate. And certainly when we deal with language, that becomes extremely apparent. And when we talk in these kind of spatial terms, or we start to think about the kind of physical properties of the world around us, I think there is a risk that we might kind of see that as being less consequential or less controversial. But yeah, of course, we know that it's significant that Louisa Moore and her colleagues are political geographers, right? They're highlighting the fact that the kind of organization of the world, the kind of an idea of spatial intelligence, is also very much kind of invested in certain kinds of power relations, certain kind of organization of the world that has massive consequences. So I do think we have to be very skeptical and alert when we talk about any form of kind of modeling the world. And I agree with you that the safety mechanisms or procedures for much of the release or and the public release of many of these models is kind of shockingly irresponsible in many cases. I mean, the kind of rush to market in this case, I think, is unlike anything that we've seen in the past. The idea that large language models are being embedded into search queries, in Google and other search engines is incredible. So the kind of threshold of acceptance of error, failure, is surprisingly kind of high. We're amazed at how good it is, and then very, I think, quick to think of it as good enough. And the ability to kind of reach, from that kind of classic problem, if you're 99% of the way there, the remaining 1% is hugely consequential. Errors in fields like, as Amor is pointing out, in migration law or decision-making jurisprudence, massively consequential. Now, of course, we see this in kind of self-driving vehicles where 99% is not safe enough. But I think that kind of threshold should be established in other domains as well. And of course, it's not at the moment. I mean, these things are being rolled out very quickly, and yeah, and I think in ways that are not always responsive. So,
Thank you. Given that, thanks for the talk, first of all.
my pleasure.
It's very interesting. Given that we kind of have solved spatial computation, right? In physics, we're very good with physics simulation, even light simulation. All of that is a solved problem in computing with much less resources than these models need. Do you have a sense of why is there this push for this spatial computation? If for most purposes, I think we have all the tools that we need. So what is the remaining part? And I have my suspicions, but I would really like to hear your opinion.
Yeah, I mean, it's a good question. I mean, obviously, we have physics engines, right? They work pretty well. So simulation technology is, kind of advanced in its kind of own way through a separate strand of computational culture. I think, well, part of it is this. I think the kind of gambit or promise that if investment in AI is going to pay off, that it must reach this kind of level of general applicability, right? That it needs the notion that our AI models have a kind of complete understanding of the world is very entrenched, right? I mean, this is what kind of needs to be the payoff. And in order to do that, then you need to have full understanding, right? Which means so the kind of emphasis on multimodal training is part of that. So if language only gives us a partial understanding of the world, then the images give us a little more, spatial data gives us a little more, movement information gives us a little more. We start to kind of build up. And if we can, if the industry can establish that, yeah, this process will eventually lead. So if effectively the kind of current technology, but at larger scales, will eventually kind of fill in that picture, we can see the kind of implications of that. So I think that's the kind of promise. But as you point out, it leaves us kind of replicating in parallel forms of technological development that already exist. I mean, we can see in the case of images that there is a payoff, right? There is to be able to, and we see a crossover of this in things like video game design, where obviously AI procedural generation has potentially certain advantages over using more traditional physics engines and production. But yeah, so but I think it is all in a way in a service of kind of feeding this kind of development of heading towards a kind of general artificial intelligence that has a full and complete understanding of the world and is able to, I mean, LeCun's goal is clear, right? He wants AI to be able to complete tasks, one-shot tasks with no supervision and very little kind of context. So you could, for example, have an AI you could instruct it to carry out tasks that it's never encountered before in ways that have no pre-existing establishment within the training data. So that's a kind of next level of generalized intelligence, which we're not at. So these are all kind of being fed in the promise of eventually reaching that threshold. Whether that's possible is one question. Whether we actually want to be moving in that direction is another question. What the implications of actually being successful, if we were to be successful, I think is all part of the question. So, but yeah, you're absolutely right. I mean, there is a kind of parallel development of all kinds of technologies and saying, well, we can do this another way, but we can also do it through generative AI, which of course is highly intensive in terms of computational resources, data resources, and so on. So it's a kind of brute force process, but we have a huge investment in actually kind of pursuing it for all of the kind of industrial reasons I've kind of tried to point out. But yeah, you're right about that.
Yeah. Cool. Thank you. So I don't want to kind of talk about the end of humanity and that kind of thing, but I think that given that there's latency in terms of the data that goes into training, especially for the layman, not for the data scientists, but for the end user, we are using the generative AI or the AI products that use data. So we take it as face value that, they tell us, this is you. We use the data that's out in the open, it's open source and it's human. This is how humans talk, this is how humans thought, or whatever. But I think now we are reaching a point where it is trained and it is starting to train our brains and how we think and talk and behave. So do you think that there's an ethical problem there, given cognition without feelings or emotion? We can't be, I can't think of cognition without emotion. And given that I can't feel emotions yet, or at least, given the models we've seen so far, do you think the way we feel emotions as humans will evolve because it is starting to train us with the data being pushed into it, which is already dated, and it's just, I just find it to be a really dark picture, but maybe preventable. So I just wanted to take your opinion on, given that cognition can't be without emotion, it can cognize, but it doesn't really have cognition per se, but it is also kind of teaching us how to cognize.
Yeah.
So.
Yeah, I was teaching a class this week where we were looking at this idea of the dead internet theory, right? Where what happens when most of what circulates online is AI generated. There's more chatbots on social media sites than there are, or social media platforms, than there are human interaction. More of the text that circulates online is AI generated than is not. More of the images that constitute our kind of life world are generated by AI. And it's, I mean, that's a slightly kind of bleak picture, right? And it's, you imagine, and I think that is part of what we're trying to understand, is the way in which if these models are trying to understand our world in some ways through our language, through our images, through our culture, but then it's recursive, right? And they then have an impact on that world itself, right? It's a second order cybernetic system, and that I think we all feel that, right? The way in which we're all kind of second guessing our career paths, second guessing how do we AI proof our lives in some ways, or become kind of resistant to the kind of threats or and so on. I mean, Hales, I really like Hales partly because Hales is very optimistic, and one of the reasons so first of all, Hales is very clear that cognition, emotion is not a requirement of cognition. Brains are not a requirement of cognition. That there are all kinds of forms of cognition within the world that satisfy that criteria, and that are radically non-human. They're not all even organic, and that having that kind of relationship with those other forms of cognition and a recognition of those other forms of cognition is a hugely important step for humans to take. We have to kind of think of how we relate to these other forms of cognition, which are radically non-human, don't have emotions, don't have memory in the same way we have all these kinds of human characteristics. And I think that is true, and I think that's a kind of important goal, particularly as we kind of face some of the kind of other crises that we're facing at the moment. But it doesn't take away from that risk that you're talking about in the way that, and it's even a kind of technical problem, right? As the more and more of the kind of data that circulates in the world is touched by AI or generated by AI or produced, that it actually can have kind of model collapse where being trained, it actually, AI does need humans, it needs human data. And so, yeah, that kind of recursivity even has kind of technical implications, let alone, ethical, political, emotional implications. But yeah, no, I agree with you. And I think we all feel that, right? I mean, it's even if you are trying to stay as far away from AI as possible, that's not really possible anymore. It's going to be in your thoughts, if not in your life. So yeah, I think that's kind of what we're dealing with, and we're having to kind of navigate and to sort of figure out what relationship do we actually want to have with this technology. And I think that's a big question. I mean, that part of the problem, and that kind of goes back to the first question in some ways, this kind of lack of safety or guardrails, or the inability to kind of slow down the process or redirect the process, is very tangible. I mean, we have, what are the systems we have in place which could redirect or reshape these models or change our relationship to the technology? Government regulation. Well, I mean, governments are highly invested in kind of moving the train forward and making sure that we're on it. So that doesn't seem like a kind of way that this is going to be slowed down. So it's very difficult to imagine. It's a classic kind of technological process which is dependent on us, but somehow not particularly under human control, I wouldn't say. I mean, that's a real problem, right?
Thank you. Yeah, that's brilliant. So just sort of thinking about predictive capacity and sort of scaling back from Earth Week 2, we were talking about the latent space where video content is pulled into pieces, and then you can get the example of how AI will learn what a moving car looks like. I was just wondering, this is just a silly example. I was thinking about where is there loads of video, and I was thinking of CCTV. So rather than putting content out, in the latent space, could there be lots of videos of, for example, silly example, but just because I think it's easy, people going into shops. Some of these people are shoplifters and some of them aren't. I would imagine they might look different, not to the human eye, but if you analyse loads and loads of videos, and then obviously the human being would have to say, well, yes, this person's a shoplifter. Would they be able to,
Would AI be able to, as people were coming into a shop or going into a tube station, say this fits a pattern of, and obviously they're huge issues to deal with bias in lots of applications. I was wondering whether or not that's something that's being done, could be done.
Yeah, I mean, it's interesting. I mean, the Earth 2 project is very much kind of based on prediction. I mean, a huge promise of all of these models is their predictive capacity, and then the ability to then kind of change the future in some ways as a result of that knowledge. And so that's a very kind of tangible example of how that kind of predictive capacity could be used, but also abused. And I think that's one of the things we do have to kind of think about is that so the abstraction of information into a kind of latent space where it's organized around salient features or notable features or information rich features is essentially the way like these models work. And so they do develop concepts about the problem that they face. But yeah, there's a kind of process of always kind of simplification or compression or subtraction from the world into the kind of latent space of the model. And so then when we kind of pull those findings back into the actual world with all of its kind of resolution and complexities and contradictions and so on, that process needs to be kind of thought about, right? I mean, we have to be very confident in the procedures of those models to feel like we could actually make decisions based on those predictions. And there's all kinds of ways that we can see that going very, very, very wrong. And what the kind of threshold of failure would be, or what the, I think it are exactly the kind of questions that we need to be asking. But of course, that is, I mean, facial recognition technology, for example, is one of the kind of dominant industries of AI and machine learning, and that is exactly what they kind of promise, that we'll be able to kind of detect patterns within data, which importantly may not even be intelligible to human operators, right? The kind of latent space finds statistical patterns and vectors of commonality and so on, which are numerical, mathematical, which are based on weights and weighted features and so on, which may correspond with the way in which we might view a similar problem, but may not. And we don't have a very good, obviously, understanding in the classic problem of the black box, which is the case. I mean, I showed sort of visualizations of latent space, but those are just representations, right? Those are simplifications of what's happening, because we kind of literally can't view latent space. We wouldn't know how to. It's a completely kind of different view and understanding of the world. And if we're going to kind of make very important decisions based on those processes and that kind of modeling of the world and that kind of latent space, then we need to think very carefully about that. But it's precisely those kind of scenarios which are being promised. The way these kind of technologies are deployed in, policing activities, in immigration activities, in the sphere of war. These are kinds of exactly the places where there's a kind of promise of this deployment, and they're the most kind of ethically fraught locations possible. So yeah, I mean, those are exactly the kind of questions we have to ask, I think.
I was going to ask your opinion on whether AI could ever fully accurately recreate a world and do accurate physics simulations if it's not really using any sort of scientific method. It's just using pattern recognition. For example, I was reading this book on the way here. It talks about how the difference between just seeing objects falling and then thinking, oh, all objects that aren't supported must fall, and having a true like understanding of gravity. And therefore, can AI ever fully really understand well, or not understand, I guess. I guess it doesn't have to really understand it, but can it ever properly simulate and accurately simulate the world if it doesn't understand these principles?
Yeah, I think that's exactly the right question to ask. I mean, the title of my talk is "Faking Physics," right? I mean, and that's kind of what it's doing and what it does in all domains. I mean, Alex's talk demonstrated this brilliantly in the sphere of language. It's incredibly good, surprisingly good at maintaining the kind of facade of intelligible conversation. There's a big difference between that and actually, having the kind of understanding of the world, which, an actual understanding of the processes in which it's emulating or mimicking or and so on. Um, so I think that's exactly the right question. I mean, I think the interesting thing about the models is that, and Alex touched on this similarly in terms of ChatGPT, is that it's more complicated than just saying, it's not exactly one or the other. It's not that it's, oh, this is complete facade, right? It's just comprehending the movement of pixels on a screen and replicating that in a way that's kind of convincing, but has no idea, the kind of context of the scene or the relationship of objects to other objects or the kind of way in which objects behave in movement or all these kinds of things. It does have some understanding of that, or at least it's able to kind of abstract kind of concepts of those things in some ways. But as you're pointing out, the kind of underlying kind of understanding of those processes is at best very limited, right? But I mean, the interesting thing about these generative models is you actually can learn quite a lot about the world through representations of the world, right? So you can learn a lot, and Hales explores this really kind of effectively. You can understand a lot about human emotions, human relations, and so on through our language. And so you get the kind of bizarre interactions with, ChatGPT, where it says, yeah, no, I don't feel emotions, but I can tell you what the emotional resonance of this poem is, and do it in a way that's relatively convincing because, our understandings of the world are partly established and reiterated and reinforced through our representations of the world. So representations of the world are not insignificant, and you can learn a lot about the world through, the entire catalog of human motion images, for example. But as you I think rightly point out, that doesn't mean you have a kind of fundamental understanding of all the processes that are being represented. And so the gambit at the moment, or the kind of debate at the moment is, well, does that just mean we need more representations? So more data, more different, so that more multimodality. So if we could access, so for example, if we could link, you know, robotics. So if we actually had a kind of embodied AI that did actually move through the world and had a kind of understanding of spatial relations and so on through that, would that be the kind of missing piece that would kind of add to the puzzle and so on? So is it just a matter of kind of accumulating different forms of representation of the world in order to build up the puzzle, or will that always be limited, right? Is there something else missing? And I would be of the school that yes, that's always going to be a kind of partial understanding. But yes, but I mean, one thing obviously it is kind of leading to is the idea of, well, how do we understand the world, right? Like, how do we come to a kind of knowledge of physical properties? And it's not always, it's not because we necessarily understand all of the underlying processes either, but we develop kind of different understandings of the world based on our own limited information and knowledge of the world. It's just a different set of limitations, I suppose, right? But yeah, I mean, I completely agree with you. I think from my point of view, there's a threshold. But I'd be interested if people disagree with that. And it's probably not a bad thing that there's a threshold.
You kind of gestured at some of this a little bit, but I just wonder if in some of these discussions, people pull apart things like being a model of the world in the sense that I might have like a little model on the table in New York City, versus something which is structurally just like New York City, but not necessarily a model of New York City because, I mean, these are things I talked about last week, but because of its history or its intentions, it just happens to sort of be structured the same. So I think that those seem to me to be sort of importantly different. And then there's another sort of third thing, which is something like, well, we might be able to build something like a model of the physical laws by having a bunch of image things that follow some rules, where those rules look like the laws of physics. And that's like, in a way, that's a world model, but in a way, it's more like a laws of nature model, and then it's totally independent of like what stuff we sort of plug into it. So I just wonder if like these kinds of differences are so one is a very abstract sort of just, here are the rules that the world follows. And another is something like a structure, which might be isomorphic to our world, but may or may not be a model of our world. It might be a model of a twin world. It might be a model of a duplicate world, but it's structurally the same. And then something that's like really referentially about this world. Do you think that stuff gets teased apart, or do you think it kind of just gets all run together?
Yeah, that's a good question, right? I mean, so if we have a simulation of the Earth, what exactly are we simulating? Are we simulating an Earth that behaves in Earth-like ways, that in some ways has some kind of correspondence to the basic structure of our Earth, but otherwise has no kind of direct relationship to it? Or are we actually trying to kind of model something that is has some direct correlation, to our world, maybe even kind of in real time or so on. I mean, the promise of the kind of digital twin project, which expands beyond just NVIDIA and AI, it's a whole realm of, it's the kind of next version of the smart city kind of discussion of how can we have digital representations of the world that are actually indexically tethered to the world. So it's a simulation that's not just a kind of theoretical simulation that replicates kind of basic structural patterns, but is actually connected. And the promise of these digital twins is that actually that bridge will be overcome, so that you can have, for example, city data in Earth 2. In Earth 2, you can actually, the promise is that you can scale down to kind of street level. So you can look at, the movement of weather patterns, which could actually be based on actual data from the Earth and could be both predictive, but also actually potentially real-time simulation. But then you could kind of scale down to the level of, city, streets, operations, which theoretically could also be being fed with real-time information. So there, the link between the simulation and the world becomes more directly correlated. That's another one of these areas of huge, kind of promise in technology circles. This is another kind of holy grail of technology, the idea of kind of real-time data simulation at the level of cities, at the level of planetary level, and so on. And yeah, it doesn't often get realized. And so the promise is often much greater than the actual realization. But yeah, that is one of the things that it is a sort of, it's a kind of mandate or mission of a lot of kind of technology is that it will actually, yeah, we will be able to simulate not just a world, but our world. And therefore, the kind of predictive power of those simulations will be very much more indexically tethered to our actual world. And that's where the kind of power dynamics, I think, really get played out. So I guess an answer to the question is that I think definitely at the moment, certainly from the kind of generative AI side, it's another world that might have some resemblance to our world. But the promise is much more on the lines of that actually this will be somehow kind of incorporated, tethered, indexically linked to our actual world. Is that kind of the level? Yeah, okay. It's an interesting, yeah, it's an important question, I think. Yeah, it's the complicated nature of simulations, right? Like what exactly are you simulating and what is its relationship to the existing world? I think we've reached time. Thanks for the excellent questions. Thanks to our online audience. Reminder, November 28th, Kinga, December 3rd, Felix. I'm really looking forward to hearing those talks. Please join us for a glass, a chat, and thank you very much.